Good day, this is the update. I'm just playing around with the Figura generator. And I'll show you what I got here. I got 5 MOSFETs. They're on H bridges, but I'm just using one side pulsing. All right, the lights are showing how they're firing. They're making before breaking, so it never loses the field. So one fires, then the other fires, then this one goes off. Then that one fires, then this one goes off. And that one fires, and this one goes off. So basically, it makes the connection to the next one before it breaks the connection to the previous one. And that's the frequency I'm using. Really, it doesn't matter what it is. But here we go. So out of each one, I'm going through chokes this time. 4 chokes. And I'm using chokes because people are saying reactive resistance from coils is what you need. And the Figura patent shows some type of coils, kind of like stretched out springs. But anyway, I'm using these for now just to test, just to see what happens. So it's going, and we have our undulations, the one emptying and one filling. Not as extravagant as before because we're not using big resistors. Now, each of these chokes is like, I don't know, a quarter of an ohm, maybe like 0.3 of an ohm. So 3 of them, if it goes into the first circuit, it goes through 4 of them. You're maybe adding like 1 ohm, 1.2 ohms into the circuit, which isn't really gonna resist it much with 1.5 amps. So you're not gonna lose much voltage. So I'm not gonna see big variations of the light. The only variations you're gonna see is when an initial pulse comes and it reacts and it creates back EMF. At that point, you'll see your voltage lower, and that's what we're witnessing with these bulbs here flashing. Now, these diodes here with the red wire aren't really doing much at the moment, but because it's not a commutator, I have to use diodes coming out of the H bridges, because the way these H bridges work, when you turn off a terminal, it becomes a negative. And that might be some of the issue, uh, that I'm having now. So I'm going to have to think about that. But these diodes here are in case the reactance coils that I'm using as resistance has any back EMF coming back, it would be able to come out and go back into the battery and not just be blocked. In case that's important, I don't think it's doing much now, but I want them there in case I do stumble upon something that needs it. Anyway, yeah, so I did try hooking up a 3-coil transformer to see what happens. There's induction, but so far I can't see anything that's bypassing lens fully. Maybe some. It's hard to tell exactly. I haven't done too many measurements. But anyway, I'm just toying around with it, showing you what we got going. We do have the action going. Not as extravagant as before because we aren't using big resistors. We're using reactive coils as the resistance. Here's our new scope shot of both light bulbs, positive of both light bulbs, and tying the negative together. I'm going to stop it. As you can see, one's growing while the other one's fading. They're both up in a positive zone because they're both positives, and they're pretty much doing what we think. The steps, look at the blue one, the big step, smaller step, smaller step, smaller step. Now, it's a little offsetting and weird because let's put this on the 0 line. Right? Alright, that's on a 0 line. This is actually direct current up here, but these pulses are taking away voltage. Okay, so when it pulses, it actually takes away voltage out of the light bulb. No, yeah. I don't know. It's a little weird. I can't really comprehend it. And this one does the exact same thing, but just at the different timing. Whereas one's growing, the other one's diminishing. I think this is correct. What it's supposed to look like, kind of. But I don't know. Just getting a feel for it. And that's what we got going. So if I discover anything interesting, I'll update. But I don't know.